Hi, and welcome to a video introduction to programming in C and C++. Over the last few years, there has been an explosion in the interest and excitement to learn these powerful languages for both personal and career reasons. Magazines are filled with articles praising the benefits of C++ and how it is used in a relatively new style of programming called object-oriented programming, or just OOP for short. Historically, most new programmers have been told to gain a background in another language like BASIC, Pascal, or COBOL before attempting to deal with the complexity of C. However, this may be a wrong approach. In fact, many people have insisted that a background in the other traditional first languages can often make learning C much more difficult, because C is so much unlike these other languages. Newspapers and recruiting magazines are filled with positions for both entry-level and advanced C and C++ programmers, but the best positions are offered to those with experience in specialized areas like Windows development, OOPs, Unix, and networks. Well, in this one-hour tape, we'll give only a gentle introduction to the basics. We'll start off by covering everything from the basics of C and structured programming through to some specifics of C syntax and concepts like structures, pointers, files, and even some of the basics of C++ and object-oriented programming. Let's start off then with a quick look at where we'll be going in this tape. We'll be covering the hardware and software needed, the world's smallest C and C++ programs, background of C and C++, basics of C programming, structures, arrays, and pointers, working with files, working with larger programs, basics of OOPs and C++, and finally programming in C++. Hardware and software needed. Let's start off by looking at the kind of equipment and software needed to begin programming in C and C++. The C language can be used on any size of computer with a software program called a compiler to translate the commands typed in into the computer's own language. Older C compilers can fit in one diskette, while some of the newer C and C++ compilers require upwards of 30 megabytes of hard drive space to use effectively. Many new C programmers were surprised to learn that C compilers are available for almost every low-priced personal computer, including the Radio Shack Coco 3, the Atari, the Amiga, Macintosh, and of course the common PC. Newer compilers tend to be easier to work with since they provide an all-in-one integrated environment that lets you access all program options from menus by using a mouse. Every different C compiler will bring with it the standard C code routines plus a unique set of routines specific to that computer brand or compiler brand. It's certainly not difficult to find C compilers to work with on a PC. Some of the main brands used in industry include ones by Microsoft, Borland, Lattice, Sortec, and Aztec. However, the situation is quite a bit more involved when it comes to finding a C++ compiler. C++ compilers are much larger programs and require much more computer power to operate, and are very seldom used in systems with less horsepower than a 486. Many recommend that a good basic setup for serious C++ work should include at least a 486SX computer with a 200 megabyte hard drive and about 8 megabytes of main memory. The Borland C++ compiler, for example, comes with a box full of manuals weighing well over 20 pounds and can intimidate even the most seasoned computer users. So as a result, many people choose to learn C first and then proceed to C++, since most of the skills learned in C can be transferred over anyhow. The price of equipment and software is certainly not a problem when programming in C. Choosing the right C++ compiler can be a challenge, though. Borland Corporation, for example, provides many different configurations for every application. There are DOS versions, Windows, OS/2, and countless other resource toolkits and code libraries available. Today, most PC-based compilers can be purchased in both DOS and Windows versions and are usually available in either a standard or a professional developer edition, which usually costs several times more. Most programs produced for resale in today's market must work within the Windows environment, which can greatly complicate the programming project. Many excellent C compilers and C training programs can also be obtained free by using a computer modem to phone what are called computer bulletin boards. Still, the only way to really learn how to program is to practice the craft. Smallest C and C++ programs. Let's begin by starting up an older Borland Turbo C compiler by typing the letters TC from the DOS prompt. The Borland's programming environment provides a good workspace with menus to help you enter code, run it, and view the output. By pressing the Alt key and the first letter on any of the menu options, we can choose an option. The workspace of modern compilers is often referred to as the IDE, which is short for the Integrated Development Environment, which provides many useful utilities like project makefiles and debugging routines. However, most advanced programmers choose to work at the dot prompt because of the extra flexibility it offers when assembling larger multi-file programs. Most new users are better off working in the menu system to start with, at least in the beginning. Let's start now by creating a basic C program to print the words Hello World on the screen. Every program should start with a comment line, which begins with a / and an asterisk and ends with another asterisk and a /. Most programs will then have an include file, which automatically brings previously written code or functions into the current program. Every include file begins with a number sign, followed by the word include, and then in brackets or quotation marks, the name of the file to access with no semicolon at the end. Then we type in the main function, which is required in all C and C++ programs, and then enclose all program statements within a set of open and closed braces. To print our greeting, we use the most common built-in C function called printf, which is not used in C++. By selecting the run command, and the program will automatically compile, link, and run our program, and put our greeting onto the screen. So to recap, every C program will contain the following parts, which we'll discuss in more detail later: a comment section, one or more include statements, some global and local variable declarations, a main routine, and one or more functions or calls to outside library functions. Here now is the C++ version of the same Hello World program. C++ comments can be identical to C or a little different, and the include file called IOStream replaces the C file standard IO. To print a message in C++, you use two left-pointing arrows to direct the message to the cout command, or if you want to get input from the keyboard, you reverse the arrow's direction and use the word cin instead of cout. Here we see both the C and C++ versions on the screen, but it must be noted that though a C program can be run in a C++ compiler, the reverse is generally not the case. The two languages differ in how they handle input and output to the screen and to a file. They use different include files, have different file name extensions, and C++ makes use of more symbols like the right and left pointing arrows and abstract concepts like streams, classes, and manipulators. It's very important with both of these languages to be very careful with how you use punctuation. The main function must have two brackets right after its name, and the contents of the main function must be within two curly braces. It's often easier to put a semicolon after every line in a program and then remove the ones that aren't required later. It should also be noticed that the include files will either have angle brackets or quotation marks around them. The quotation marks tell the compiler to look for the file in the current directory, while the angle brackets direct the compiler to the search path specified in the program's default setting. Now, C is not the world's most forgiving language. Every bracket and brace must be in its proper place, and even C++ forces the programmer to outline everything about each function in what's called function prototyping. A few missing semicolons can generate a page full of warnings and error messages after a compile. Background of C and C++. The C programming language was created at the private research facility called Bell Labs during the 1970s when work was being done to develop the Unix operating system. Ken Thompson, a Bell employee, had written the original Unix version in assembly language and then created the B language to make improvements to it. Dennis Ritchie, also of Bell, then modified the B language and called it C, and then rewrote the Unix system using it. We have at least one reason now to thank our telephone company. C is considered a programmer's language due to its great flexibility, power, and its odd appearance. It can access memory locations to produce fast routines and is not as hard to use as assembly language. One of the major benefits of C is its portability, which allows C programs to be easily transferred between computers. More complex programs require the use of larger memory models found in more expensive compilers. Basically, a computer's memory is divided up into segments that can store both data and code, and more complex programs need to access more of these areas. Virtual reality programs tend to favor the use of C or C++ because of their use of gigantic data files in some CAD programs and complex graphics files. Now, C++ is a language built on C and adapted to support object-oriented techniques. It adds many new features to C without sacrificing much of the power and flexibility of it. It was written in 1980 by Bjorn Strustrup, also a Bell Labs employee, and was originally called C with classes. It has undergone several revisions over the years and became known as C++ in 1983. Many say that the name C++ was derived from the fact that in C, C++ is a command used to increase a variable's value. Though C++ isn't a true example of what's called an object-oriented language, like Smalltalk is, it does require a new way of thinking, where programmers must learn how to describe everyday things in terms of software objects, like bottles, cutters, and even hockey pucks. Unlike the traditional way of programming, where program functions are written to work on data, object-oriented programming mixes together data with functions to form a combined unit called an object. Here's a quick explanation of some buzzwords used in OOPS and C++. A class is a new data type that combines both program code and data and is used to create objects. Classes look almost exactly like C structures. Methods are like functions, and messages are like function calls. Overloading is a term that applies only to functions and operators in C++. A function is overloaded when several functions all share the same name, and is how the term polymorphism is achieved. Polymorphism is the ability of an object to respond to general-purpose messages in different ways. Early and late binding refers to the point in time when code is brought in to be used by a program. Encapsulation is the packaging of both code and data together. Inheritance allows one object to take on the properties of another object by copying the desired properties over. Abstract data types are new data types created by combining existing data types in new ways. A stream is a technique that uses an open command to allow C to handle files and hardware devices. Constructors and destructors are pieces of code in C++ to create memory for a routine and then erase it when it's no longer needed. Function prototyping makes the programmer specify more information about each function's type and number of arguments. We'll deal with hockey pucks later.